Hi everyone, welcome back to the Code to Conquer series, your step-by-step guide to mastering DSA for placements. This campaign is brought to you by the Google Developer Groups at VIT-AP. Now we completed the first question of day 16, which is singly linked list. So now we'll go to doubly linked list. So what do you mean by a doubly linked list? The only difference between a singly linked list and a doubly linked list is that in a singly linked list, you can only move in one direction, that is towards the forward. But in the case of doubly linked list, you can move to both forward and backward. So every node in the doubly linked list will be having two pointers. One is the forward and the other one is backward. So with that information, with this basic information, let's see what the problem statement is. So similar to the problem 1 of today, of day 16, we have to create methods for inserting and deleting nodes from a doubly linked list. So coming to the description, similar to the problem 1, we'll be given with the key and position for insertion and just the position for deletion. So according to these, we should perform our operations. We should create a method. We should create methods for insertion and deletion. Now coming to the test cases, they are similar to the ones we did in problem 1, but let me explain them once more. So 0 stands for insertion, 1 stands for deletion, position and key. This is the format of the input. So we are given with 0, 1 and 10. So we should be inserting 10 at the first place. We should be inserting 20 at the second place. We should be inserting 30 at the third place, and we should be inserting 40 at the fourth place. So if we traverse through our linked list, we'll be having the output like 10, 20, 30, 40. So in the second input, we should be inserting 10 at the first place, inserting 20 at the second, and we should be deleting the second node. So we'll be removing the 20 from our linked list and we'll only be left with 10. Coming to the third one, we should be inserting 10 at the first place and deleting the first node, which means deleting the node which we just inserted. So our linked list will be empty and we'll have an output as null. So coming to the next one, we should insert 10 at the first place, 20 at the second, 30 at the third. We should be deleting the first node, that is 10. So we'll be left with 20, 30. We should be inserting 40 at the first place. So we'll be having 40, 20 and 30. And we should be inserting 10 at the fourth place. So we'll be having 40, 20, 30 and 10, as we can see in the output. Now let's come to the coding part. So similar to the linked list, we'll be having a node class with a constructor node, which will be having key as the input, which will store the data for the node. And as I told you, we'll be having two pointers for every node. One is the next pointer and the other is previous. So initially both the next and the previous will be pointing to null in every node we create. So we'll be having our head node, which we should not tamper, as I told in the problem 1. It is important to keep the head node aside without doing anything to it, because if we change the head or we do something to the head, we might face problems in the future. So we have our insert and delete. So let me explain them. Now coming to the insert and delete, so we'll be given with our key, the value and the position. We'll be given with the key and the position. So we should be inserting key at the required position. So the first step, as in singly linked list, would be creating a new node with the key. We should always focus on creating a new node with our key given. So first step would be creating it. Next, similar to the singly linked list, if the position equals 1, which means that if we want to insert the new node at the first position, then we have to perform this. If the position is 1, we have to perform these 3 steps. So what do they say? We'll be creating a new node, right? The new node should be pointing to the head. The head should be renamed. The new node should be renamed with head. This is the basic, this is what we would be doing basically in a singly linked list, but this is a doubly linked list. So we'll be having our linked lists like this, similar to this. Let's assume there are three nodes in our linked list and we want to insert a new node. So what can we do? We have to, and the previous of this is pointing to null and the next of this is pointing to null. All right, so how do we want our final no, this thing linked list to look like after performing operations? We want our linked list to look like this, right? So what can we do? Let's do one thing. Let's point, this is new node and this is head. So let's point the next of new node to the head. First step is done. Now let's forget this if condition. The head's previous was initially pointing to null, but now it should be pointing to the new node, right? It should be pointing to the new node. So we created what we wanted. So this is exactly what we wanted as I previously drew. The head, the new node will be renamed as the head. So this will not be a new node anymore. This will be the head. So if we traverse to the linked list, we will first have this, and we'll have it like that. So this is the thing. Now let's come to this if condition. What does this if condition state? Why is it there? So assume there are no elements in a linked list and we are given with inserting 1 at position 1. So we'll create a new node with value 1. Next we'll head equals null right now because there are no elements, and this points to head. So this points to null. And what did we initially say? We should also make the previous of head to the new node, but head currently is null. Does null dot previous have any meaning? No, it does not. So what should we do? So we should also consider this if statement. So this is also important. If there are no elements in our linked list previously, this will become crucial. If this is not there, we'll have a null pointer exception or something. Sorry, not an exemption. Exception. It's an error. Null pointer error. So we should also have this. This is important. Do not neglect this. So we understood what if the position is 1. Now let's look at the case if the position is not 1. Similar to the singly linked list, so we'll be having our pointer. Now it's temp. So we'll be having a temp pointer pointing towards the head, and we'll move the temp pointer till the node after which we want to insert. For example, if we want to insert it at the third position, we'll be sending a temp pointer till the second node. Let me just draw it. Yes. So assume there's a doubly linked list like this. Let me draw one more. Yep. So this will be pointing to null and this will be pointing to null. So you want a new node at the third position. Assume it's like 1, 2, 4 and 5. Right, 1, 2, 4 and 5. You want a new node at the third position. So how do you want it? 3 should be over here. You want it like this. So the previous of 4 should be pointing to 3 and the next of 2 should be pointing to 3 and the previous of 3 should be pointing to 2, previous of next of 3 should be pointing to 4. You want it like this, right? If we want to insert 3 at the third position. Else, yes, okay, not else. So this is our initial linked list. So what can we do? As I told you, first this is our head, right? So we'll be pointing a pointer temp over here and we will be moving till the node after which we want to insert. So we will be moving till here. Now let me just increase its size. Let me magnify it. So 2, 4 and we want our node 3 over here, right? So this is our initial linked list. So what can we do? This is our new node, this is our temp. So what can we do? First thing, let's do one thing. Let's make the next of this new node as the next of temp. What is the next of temp? It's 4. And if we make the next of new node to the next of temp, this will happen, right? Now, let's make the temps next previous to be the new node. So what does this mean? What is the temps next? 4. What if we make the previous of 4 to be 3? So this will be gone and we will make the previous of 4 to be 3. So if to be clear, I will write the things down. The first thing we did was new nodes next equals temps next, right? 3's next will be temps next. Next, after this, what did we do after this? We made sure that temps next dot previous equals new node, right? This is the first one, this is the second one. Temps next previous equals 3. So I hope you got the first 2 steps. Now this is what we will be having right now. So what can we do? Let's make the temps next to be the new node, right? So let's make the temps next to be the new node. And there's one final step. We should make the new nodes previous to be the temp. So this is also gone after we make the temps next to the new node. So we finally have the result how we want our linked list to look like. So let me also draw write down the third and the fourth step. The third step would be one second. The third step would be temp next equals new node and new nodes previous should be temp. I hope you're getting my point. So I'll just summarize this. We should be moving till the node after which we want to insert. We'll be creating a new node. We will be making the next of new node to be the temps next. So we'll be making the next of new node to be the temps next. Next, we'll be making temps next previous to be the new node. Temps next previous to be the new node. Next, we'll be making temps next to be the new node. And finally, the new node's previous will be pointing towards the temp. So finally, we inserted 3 between 2 and 4 or at the position 3. So we inserted 3 at the third position as we wanted. So our linked list will finally look like 1, 2, 3 and 4, right? So we have a linked list. This will be pointing to null and this will be pointing to null. So this is exactly what is written over here. See, new nodes next to be temps next. Forget this if condition for now. Temps next of previous should be the new node. Temps next should be the new node. New node's previous should be the temp. Now let's look at this if condition. Why is this if condition there? Now if the temps next equals null. So let me give you an example. If we want to insert a node at the 5th position, right? So our temp will be over here, right? And the second step would be temps next dot previous equal to new node. What is temps next? In this case, null. Does null dot prev have any meaning? No, it does not have any meaning. So we write this if condition to check if we are at the last element. I mean, if the temp is at the last element and we want to insert after it, we'll make sure that we do not have this condition to be running. If we'll run this, we'll be having errors, null pointer errors. So make sure that you write this if condition. Other than that, there's nothing else. There's the 4 steps that I wrote and this if condition. While traversing, if the temp reaches null, immediately stop this execution because the temp is going to its next node. And if it reaches null, there is no point of having next node to the null, right? So we should immediately stop execution of this for loop. So this will be done and will be reach. And if the temp reaches null, just print that the position given is invalid and return so that these steps will not be executed. So to summarize, first things first, always create a new node with the key given. Second, if the position equals 1, just make sure that you execute these 3 steps. New nodes next should be pointed to head, and if the head is not equal to null, make its previous new node, and head should be a new node should be renamed with head. Else, if you want to insert it in between the linked list, similar to the singly linked list, perform this with the temp pointer and move it till the node after which you want to insert, and finally perform these 4 steps to insert. So I hope you understood the insertion part. Now let's go to the deletion part. Coming to the deletion part, if the will only be given with the position but not the value, because we do not care for the value. If we want to delete the node at the second position, we do not care. It's none of our business if it's 20 or 30 or 40 or whatever. We just want the position we want to delete, and that's it. So if the head is null, what does this mean? There is no element in linked list. The linked list is empty. So can we delete anything from an empty linked list? No. So just return, right? Next, if the position equals 1, similar to the single linked list, just move head. See, 1, 2, and 3. Assume this is a linked list, right? So if we want to delete the first, I mean if the position is 1, just this is our head, right? Just move head to its next node. So this will be our head right now. And make sure that you also remove the previous. Make sure that this head is not previously pointing to anything. I mean its previous is not pointing to anything. So make sure that you remove this as well. This pointer should be gone. So finally our linked list should be like this. Let 1 point to 2, it's none of our business, we do not care about it, but the previous of 2 should be pointing to null. So I hope you got what is this for. If the position is 1, just make sure that you perform these 2 steps. Now what is the point of this? So assume we are only having one element in our linked list. Assume there is only one element and it's pointing to null and it's pointing to null previously and both next and previous. So and you are given with the position equals 1. So you will be moving head to the next node or next. So head will be null. Does null dot previous have any meaning? No. So if head equals null, do not run this. Only run this if head does not equals null. So I hope why is this if condition there, and what should we do if the position equals 1. So coming to the next lines of code, similar to the linked list, but there's a slight change over here. Previously we will be moving till I is less than position -1, which means that we will move till the pointer reaches the node after which we want to insert. So if we want to insert at the 3rd position, we'll be moving till the 2nd node. But here, if we want to delete the 3rd node, we will make sure that our pointer reaches the 3rd node. So if there's a linked list like this, and you want to delete the 2nd node, you will previously, if you want to insert at the 2nd node, you will make sure that your temp is over here. But if you want to delete the second node, you will make sure that your temp is exactly at the point where you want to delete, exactly on the node which you want to delete. So that is why instead of I is less than position minus 1, we take I is less than position. So this minus 1 goes and we'll move one step further than the previous ones. So I hope you got this for loop. We'll be moving till the node, on the node. We'll be moving on to the node which we want to delete. Now, if the node we want to delete is null, I mean if the temp crosses our linked list and goes to null, we cannot delete anything. So just display invalid position and return so that these steps will not execute. So what did I tell you guys? If you want to delete the second node, make sure that your temp is on the second node. So if you want to delete this node, make sure your temp is over here. So this will be like this, this will be like this, this will be like this, and this will be like this. So how do you want your linked list to look after deleting the second node? You want it to look like this, if I'm not wrong. This will be pointing null and this will be pointing to null, right? So you want to make sure that this comes down to this. So what can we do? Just perform these two steps and everything will be sorted. Forget these if conditions for now and just look at these lines of code. Temps, next, previous should be temps previous. So what is temps next right now? 3. And we are asking 3's previous. Temps next is 3. Temps next is 3. And we are asking 3's previous to be temps previous. What is temp? Is equal to 2's previous. Which means, what does this mean? We are asking 3's previous to be 1 because 2's previous is 1, right? So I hope I'm not confusing you guys. So in this 1, 2, 3, 4, we are asking temps next previous to be 1. So we are asking to remove this and make this happen, right? And next, temps previous next should be temps next. What is temps previous? We are asking its next to be temps next. So we are asking to remove this and temps previous next should be temps next. So we'll be having a linked list like this. So 1, 2 and 3. 3's previous will be pointing towards 1, 1's next will be pointing towards 3, 2's next is towards 3 and 2's previous is towards 1. Now we just have to make sure that that's it. We do not care if 2's next is pointing towards 3 and 2's 1 is pointing 2's previous is pointing towards 1. If we traverse to the linked list, we'll only have 1, 3, right? If assume this is our head, what is the next node after traversing through it? We'll have 3 but not 2. We do not care if 2 is pointing towards 3 or 1. So our job is done over here. So we successfully deleted 2. This is what we wanted. This is what we got. We do not care if 2 is pointing towards 1 or no. So let me also explain why these if conditions are given. So assume a linked list like this. So if you are told to delete the last element or the third element, so what did I tell you? If you want to delete nth element, move your temp to the nth node. So your temp would be over here. So what is the first step? Temps next previous should be temps previous. So what does this mean? What is temps next? Null. We are asking null's previous. Does this have any meaning? No. So if the temps next is not equal to null, run this statement if and only if temps next is not equal to null. If temps next is null, which means that if the temp is at the last element, so its next is null, do not run this. But if it is not the last element, we can happily run this. So I hope you got the meaning of the first if condition. Now coming to the second if condition. Assume you are asked to delete 1. So this will be our temp right now, right? If you want to delete 1, you will be having your temp over it. This is our temp. Temps previous next should be temps next. What is temps previous? Temps previous equals null. Does null dot next have any meaning? No. So what does this mean? If we want to delete the first element, do not, do not run this statement. So run this statement if and only if and only if we are not at the first element. So if temps previous equals null, if we want to delete the first element, do not run this. Run this if and only if it's not the first element that we want to delete. So let me summarize everything once again. First thing, if head equals null, return, because we cannot delete an element from an empty linked list. Next, if position equals null, just move head to the next, move to its next, and if the head, if it does not equal head, it does not equal null, then we can make its previous to null. I explained it right. If there is only one element, head will move to null. There is no point of having null dot previous to null. So make sure that head does not reach null. If it reaches null, this step should not be executed, or else it might lead to some errors. Return, so that these conditions will not be these conditions will not run if our position equals 1. So, or else make sure that you create a temp pointer at head and move till the node which you want to delete. Also make sure that temp does not reach null. If it reaches null, just stop immediately. You do not want to go to its next node, because null dot next does not have any meaning. So if temp reaches null by any chance, just display that it is invalid position that is given and return, so that these lines of code will not be executed. Next, if temp dot next does not equal null, if the temp is not at the last element, run this. If the temp is at last element, do not run this. If the temp is not at the first element, run this. If the temp is at the first element, do not run this. So I hope you understood this as well. So this completes our deletion part as well. So let's go to the code again. Coming to the code, as I previously explained, we'll be having an insert, we'll be having a delete, and we'll also be having a display similar to the singly linked list. So we'll be having a temp pointed towards head, and we will traverse it next till it reaches null, and we'll also display its value. And we created a small function for taking input of what we should be doing for insertion or deletion or to exit. So if it's insertion, we'll be taking our position key and we'll be sending it to the function. If it's deletion, we'll be taking our position and sending it to the delete function, and we'll be displaying after everything. So, and this is a main method. So I hope you got this. Well, this brings us to the end of this day. We completed our two problems, which were singly linked list and doubly linked list successfully. So I hope you at least got some information about the insertion and deletion in both singly linked list and doubly linked list. Let's meet tomorrow. Until then, thank you.